3D 打印已经是热门的话题，但是大家听说过3D 打印心脏呢？让我们欢迎 Matricelf。
The human heart is an amazing machine. It pumps blood into the human body 24 hours a day, 7 days a week, 365 days a year for an average of 80 years. Cardiovascular disease is the #1 cause of death globally. Heart failure needs organ replacement and heart transplantation. Without organs to make the replacement, many patients will simply die waiting for an organ. In April 2019, our company printed the world's first human heart at Tel Aviv University. We combine tissue engineering with regenerative medicine. This is the perfect cooperation between technology and modern medicine. We are currently preparing our clinical trials, and once approved, it will save millions of lives globally each year.
My name is Asaf, and I'm the founder of Matricelf. And what we are doing is a 3D personalized organ printing platform. So what's tissue engineering all about? In tissue engineering, we take cells from the human body, we cultivate them in two-dimensional cultures, then we move them to 3D scaffolds, adding some nutrients, nanoparticles, growth factors, and at the end, we get a tissue that we can implant back into the human body. Now, there are many companies in the world that are doing tissue engineering, but we are the only company that uses both the cells and the matrix from the same patient. Let me show you how. Basically, we are taking a small biopsy from the abdomen. We are separating it to stromal cells and to induce pluripotent stem cells, and to extracellular matrix. We're taking this matrix to create a hydrogel. And within this hydrogel, we are differentiating the pluripotent stem cells to the tissues that we want to put back into the patient. Our technology was published all over the world in the most leading scientific journals. And let me show you a little bit of what we are doing. This is myocardial infarction. There is an occlusion of an artery, and a part of the heart is not receiving blood and oxygen, and it simply dies. We know in our lab to create a myocardial patch and basically put it on the infarcted area, and within days, it incorporated into the heart tissue and starts function as a heart. The only problem with this solution is that you need to open the chest in order to apply this patch. So we thought of a better idea how to do it and decided to develop the gel. The gel, as you can see, is liquid at room temperature. And when it hits body temperature of 37 degrees, it's solidified into a gel. So now we can basically inject our gel or our tissue back to the patient. Once we have this gel, we can start printing organs with 3D printers. What you see here is a heart that we took only the blood vessels. We created the schematic drawing of these blood vessels and sent it to the printer. And you can see that the printer started printing this blood patch. At the end, we can basically take this patch, and when we inject blood into it, you see that blood flows into those blood vessels. And just to prove those are blood vessels, we send it to electron microscopy, and you see that it has fibroblast and endothelial cells. But this is, my friends, is history in the making. Because in April 2019, we were the first company in human history to print a human heart from a human biopsy in a 3D printer. You can see it passing around. But as I said in the beginning, we are a platform. And we can print other organs as well. And this is a study that we are doing on spinal cord injury. We take mice, we cut their spinal cord, we print a new spine for them, and implement it. And you can see over here in the untreated group that one leg is not functioning. But when we injected our hydrogel, 60% of the mice started walking again. But when we added the motor neuron cells, 100% of the mice started walking again. We are currently gearing up for clinical trials in humans. We are looking for 10 patients for a safety phase 1/2A clinical trial. And try to imagine that out of those 10 patients, only one, will move his fingers. This will change medicine forever. We have a great team of researchers, entrepreneurs, medical doctors, consultants, and we believe the future is here. Thank you very much.
好，我们把掌声送给 Asaf. That's amazing.
Thank you.
Potential for big, big change.
Thank you.
All right，我们进入我们的问答环节，同时你们可以开始拿起你们的投票器，开始投票打分数，拿起你们的打分器，开始打分。All right, our judges, do you have questions?
Yeah, when you're talking about the heart, is just a tissue, but when you're talking about a stroke, then neuron died. Do you say that you are producing new neurons?
Definitely. We're producing neurons from a simple fat biopsy, and we are using it for spinal cord injury. It's a traumatic injury to the spine for paralyzed patients.
Neuron in the brain that
No.
command it.
In the spinal cord.
So just the axon and the dendrite of
Yeah.
the neuron.
But we also have trials on Parkinson's disease, in which we know how to produce cells that are producing dopamine, which is scarce in Parkinson's disease. And we are now trying it on mice. We're injecting it to their substantia nigra in the brain and see that it produces dopamine. This will be an amazing breakthrough.
Sometimes I need some new brain cells too.